All right, anti-Markovnikov hydration. Alkene use borane. Alkyne also use borane. Look at that. And there are two steps: hydroboration and then oxidation to remove the borane. Okay. Alkyne, you get an eno, double bond still here. So use only one pi bond. So another pi bond still here. And the OH is attached to the list substitute carbon, so anti-Markovnikov orientation, and then we'll tautomerize to aldehyde later. All right. The only different in term of reagent used in the hydroboration of alkyne is the borane the use is theoretically hindered. It's a big bulky borane. Okay. So in alkene we just use BH3 in PHF. Right, tetrahydrofuran, that's a solvent. But for alkyne, so we use the big bulky borane, and here's the reason why. If we use small borane, just like in alkene, right, this borane can interact with the pi bond. There are two pi bonds in here, right? So it can interact with one of the pi bonds and add borane on to the carbon in the anti-Markovnikov fashion. Hydrogen goes on here, right? So look just like normal, and we want this borane to come out, we have to remove it with the second step, the oxidation. This is what we want it to happen. But here's the reason, here's the problem. Alkyne got two pi bond, right? Two pi bonds. Both pi bonds can react with borane. So this is the first interaction with one molecule of borane. Another pi bond can do the same thing to form alkyl diborane. And this alkyl diborane cannot convert to enol form. This is the side reaction that pull intermediate away. So you're not going to get a lot of product here. So you get less the final product. Right? To prevent double boration, so this is what we do. We use a big base. Right? Add one interact with one pi bond. Gets on there. These alkyl groups on the borane will prevent another molecule of borane to get on it. Right? To get on this double bond. And said, yeah, this happened only one time, and then you can oxidize it to the enol product. Yeah, one go to alkyl diborane, and you go all this borane intermediate will go to enol. Okay, we don't have side reaction here. So the big base that we usually use is 9-BBN, the structure you saw earlier, or borane amyl or something. That's another name. There are two common ones that they use. Okay, all right. Draw the major product here. Let's think about it real quick. Okay, so what we got here? Right, the first one, let me show you. Okay, this is the alkyne. Adding this, so mercury, this go Markovnikov, right? So OH go on there, and you get this enol, which will be tautomerized. So this is going to be double. So this looks like ketone. This is ketone. Yeah. So the mechanism goes something like that. It's not a real mechanism, but just it's explained what's going on. So this carbon is going to go get proton from double bond right here. This proton up here going to be deprotonated. You'll get ketone later. Now this is borane, 9-BBN. This is a type of borane, right? So this reaction will add water onto less substitute carbon. All right, so this triple bond can become a double bond, and you're going to get an OH on here. So you get that. And then, so tautomerization. So, yeah, the first step is deprotonation, and then protonation later. So you get that. All right, and aldehyde. Okay. All right, so the tautomerization takes time. So you make sure you go draw by yourself on a paper or on somewhere. All right, make sure you know how to draw the tautomerization. Okay. All right, now how would you synthesize the following compounds?